So we're going to do something pretty darn cool now with Python, and it will actually, it's going to be, well, it's going to be relatively Python-esque, but it's going to demonstrate a lot of really neat ideas, and it's going to be sort of this string and list combination. I'm sure the timing of this video will be pretty long, and I'll likely even break this part up a little bit. But first, to get something going that's a little bit more fun, I want you to imagine that we are going to do a text analysis on this poem. Now, I'll have a link to this poem below, but basically this is a fairly classic Monty Python poem. And if you actually know this poem, you get some serious geek cred there. But anyway, it's a great poem, and you might want to even pause the video and then get the link in the description to someone actually reciting the poem. All right, so I'm going to assume that you've done that, or you don't care. So there's cooler ways to do this, but imagine that I want to basically get this text into my memory here, right? So I've got a string. The poem itself is called Horace Poem. Now, one way I could do this is I could take this string, I could go copy and then throw it in here, and then concatenate that with, well, actually, I wouldn't even need it. I was going to concatenate it with a new line, for those of you guys that remember that, and then concatenate that with the next line. And I'm not going to do it this way, by the way, but I'm just showing you one way I could do this, right? Which is just gross. All right, so let's do that. First of all, will this even run? Probably not, because I don't have an end of line. Let's run that. And let's get rid of my shame and go next. And so that's one way to do it. But you know what? When you're dealing with big, ginormous pieces of text, probably not the way to do this. There is, in fact, a more glorious way. You could grab all this text that you're actually interested in, copy. You could then throw all that text into here, paste, and then use 3 double quotes. 1, 2, 3, 1, 2, 3. And what that does is it treats this entire block as a string. So that's a way you can get your string across multiple lines. It's also, by the way, a way a lot of people document in Python as well. If you've got a big story they want to tell, they'll put 3 quotes there, a big story about the program, and then 3 quotes there. All right, so when I go visualize the execution and I go next, we'll see this guy is sitting in memory. All right, that's awesome. Now, what I want to do is I want to do something I actually had done as part of my master's and I've done since in the corporate world. I want to do some just quick analysis on this, and I'm going to answer the question, what is the most popular word? Which word is used the most in this poem? Which word is used the most in this poem? And obviously, if you did this by hand, that would kind of suck, right? And even when I'm writing this program, probably writing the program will still take longer than I would if I just wanted to do this once. But the advantage is that maybe later I could use the same program on a different poem. Or as I did at one point, I actually grabbed all the presidential State of the Union speeches that ever existed, and I ran them through an analysis, which was a little bit more complicated than what was the most popular word. But still, it was an interesting program, and it was a lot harder to do in the language that I did it in. So Python's a pretty good deal here. So the first thing I need to do, by the way, is I got to clean this up. I got to clean this up because I've got, these kind of goofy things here. Now, what this did, by the way, is that's called an escape character. I know you kind of saw it at the end of the line to indicate, the next line. But what it's kind of saying to the Python guy is that the very next character after the slash is just a quote. There's nothing special about it. And that's great, but it's obviously screwing up my poem. What I want to do instead is I want to replace all those with nothing. That's what I want to do. I want to replace all those with nothing. Well, the cool part is that strings know stuff. Strings are objects. They know how to do things. And so what I could do is I could go string Horace poem is assigned the string Horace poem, all right, poem, and there's methods. There are programs like we saw in the previous video that actually can deal with stuff that's in strings. And of course I've left it here, but I wonder, can I find it quickly, or am I going to have to do a quick, I don't know. Let's see, come on, strings. I can't find it. Tell you what, let me just do this really quickly. Python string methods. All right. It was there the whole time. Anyway, and one of the string methods that's pretty good here is the replace. Here's the replace. So I'm going to demonstrate the replace here. What I could do is I could say, could you please replace in that string any occurrence of use single quotes, because there's a double quotes in the thing in the string. Replace that with nothing. All right. So I'm going to visualize the execution. And I'm just, by the way, I'm using this tutorial so you can see it in memory. So if I go next, this is the initial program. If I go next, now all that stuff was taken out and it's been cleaned. All right, that's great. Now, one of the things I generally don't like doing is this is straight input. I'm now hitting into the processing section. I would actually call this a work in progress or something like that. So in the end, what I end up getting is I get two variables, this guy and then the new and improved guy, but this is the variable I'm going to start modifying. All right, I'm going to start modifying here. So I want to keep my original one pretty pure and then start modifying that. All right, so there's a straight little replace. What else can I do here to sort of make this easier? Well, these little contractions, if dad is mentioned somewhere else in here, that is really the same word, dad and dad's. So I'm going to get rid of the contractions here. All right, so that's another thing I'm going to do. I'm going to come down, I'm going to do another replace. I'm going to go string Horace poem work in progress is assigned string Horace poem work in progress dot replace. Please replace all occurrences of dads with dad. I think that's fair. All right, that's fair. Let's do that. Okay, is there anything else that's obviously jumping out at me right now? I think there's another contraction in here somewhere, can't and didn't, right? So can't and didn't. So let's fix those two while I'm here. Again, normally you don't want to do too much at once, but I think I can do this one. So I'm going to go, this guy is assigned this guy dot replace. So replace can't with cannot. And let's run that guy and see what happens. So we go next. Here's our guy without the slashes, and then we get the dad. So that's up here. We're going to see that change to dad. Great. And can't, I'm sure, was in here somewhere. If I just go next, yeah, pay attention to where that actually. There it is. We can't have this. We cannot have this. All right. Good deal. So we get that going. Now there's another one which I thought was didn't. I saw didn't in here somewhere. Didn't. I can't see it, but maybe you can, because you can always pause. So I could do the same thing with didn't. So let's go copy and paste. Yeah, I still can't see it, but I'm sure it's there. So let's just go, this is didn't will be did not. All right, let's go. All right, that was right in front of my face. He didn't, he did not. All right, good deal. Now, just so you know, kind of cool, the way I could change this thing a little bit here. One thing, by the way, I'm realizing too as I'm doing this is that if there was an uppercase didn't and a lowercase didn't, this wouldn't catch it. It would only catch the lowercase. So maybe converting the entire thing to lowercase might actually be the first thing to do. So let's do this. I'll leave that replace where it is, but I'll just go here. Horace poem work in progress is assigned that same variable. Oops, that same variable. But drop it to lowercase, something that we saw in the previous video. So as we go next, we get our first video, which is just some basic cleaning, and then as we drop the case, it all becomes lowercase. And now actually that's not going to work. I have to drop that to lowercase as well. So so there you go. All right, good deal. Good deal. You probably want to do your major cleaning before you do your minor cleaning. Okay, so the other thing I want to kind of tell you is that these all seem to have to do with contractions. Python evaluates on the inside out. So this becomes a string. So I could, in theory, then just go dot and put that replace at the end of that, dot and put that replace at the end of that. And now what I've got is one line that deals with all the contractions, and a very good example of what Python actually does. So this is a string. Then when I use that method, it's going to return the same string with the dads being in lowercase. Sorry, with the dads, possessive being taken off. Then that returns that string, which I can then go and say, okay, take that string and take all can'ts and change them to cannots. That returns a string. And then take that string and replace all didn'ts with did not. And so if I go visualize execution, we'll see there's our variable that's created. It gets dropped to lowercase, and then let's just move over here and we'll see a bunch of changes happen at once. Bang. All right, pretty cool. Okay, good. Next step, I think, would probably be to get rid of some of the punctuation. We're going to get rid of all the punctuation here. So let's do that. And I can see like we're going to have commas in here. We've got exclamation points. We've got dashes. We've got ellipses or whatever those are. And then we probably got question marks. So knowing what we just learned in this guy, and by the way, you'd want to probably put some documentation to tell what you've done. I'm going to now start stripping the punctuation off. So I'm going to go, this guy is assigned this guy dot replace. So let's get rid of the commas with nothing. Okay, dot, and then dot, and then continue that vein of thought. Replace not the commas, but the question marks with dot. Replace not the commas, but the exclamation things with dot. Replace not the dash. Replace that actually with a space. And then the last guy was, have I forgotten somebody, exclamation point. Let's see what that does to our little environment here. I'm going to go replace the exclamation point. So I'm going to go. Next. Okay, so now watch what happens to my little data set. So this guy converts the whole thing to lowercase. This guy is going to get rid of most of the pluralizations and contractions. This guy is now going to get rid of the punctuation. So we're going to get rid of the, I don't have a period here, I don't think, but let's see. Boom. Yeah, so the period was left and the ellipse was left. I forgot those. Oh, and there's a colon as well. So let's go and fix those. This line is getting a little on the long side. So you know what I'm going to do? I'm going to go to the end here. And I'm going to just rip off that and go paste. And so this one, I'm saying, hey, please get rid of the period. Please get rid of the, oh my goodness, I've already forgot it. Was it exclamation? No, it was colon, I think. Colon. And it looks like I was one replace short of a picnic. So let's just do this one and then replace the ... All right, so now if we go visualize the execution, the whole point of this little exercise is to get a data set that is relatively clean. All right. I think we're, oh, semicolon, there's still a semicolon in there. I thought I got rid of that. Well, I tell you what then, that's no big deal. Grab something that's close, copy, paste it at the end, and make that a semicolon. All right. So I'm satisfied with that. Visualize, next, go, 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 go. And now we're at the end. So that, you kind of look over your data set, make sure it looks pretty good. Oh, look at that. What's is still here. What is that should be? Is there any other ones that are like that? No, there aren't, but I might be tempted to use this program later. So you know what I'm going to do? After I've gotten rid of, that's sort of a part of the contraction part. I think what I'm going to do is I'm just going to have a special line in here for the things where what's becomes what is. So I'm going to say this is assigned this dot replace, and now whenever you see one of those S's, oh, you know what? I'm not sure I like this, but whatever. That's fine. They'll do it for now. I'm realizing that if there's like a mums, for example, this wasn't really the best way to deal with this, but that's fine. That's fine. It's close enough for what we're trying to do here. And by the way, this whole thing I'm doing is there are other ways to do this, right? But I'm just sort of showing you this from a programmatical way. All right, so we got this. Good. So the set looks beautiful. Now, there is one cool thing now where we can now see sort of bridge what we've done with strings over to lists. And this will blow your mind. It'll be awesome. This will be tough for me to go through and count which is the most common word. It really would be. So what could we do? Well, there is another method out there called split. And what split does is it takes a string and returns a list. So it takes this string right there and splits it into a list right there. So what would happen if I did that same thing to my little horse program, my horse poem? I'm going to create a variable called list. It's going to be horse poem. It's not a work in progress. It is just a straight list. And what is it going to be? It's going to be this string split. Now, there's a lot more to split than what I'm showing you, but this will be good for now. We go boom, 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 boom. So all this is just cleaning. And then here, I'm going to do a split. Watch my new variable pop up. Boom. List is now, sorry, this variable is now each one of those words. Each one of those words is now part of the list. That alone is pretty good because I had to deal with this. It was something. It was something to do this in other languages. So the fact that somebody loved us enough that they wrote that every string has the ability to do certain things on itself. It can replace characters. It can split. And there's other things, obviously, too, which I'm not going to talk about in a second, but it can do stuff. So you want to look at it. And even all that punctuation stuff I did would have been much better had I used the translate. But I'm not doing that because that's just too Python-y. And the fundamentals of programming point I want you to get is understand what your variables can do, so you don't have to write a program that does it. And so in this case, I could have written a program that did this using some of the stuff that we learned before, but thank God somebody, the people who created Python said, you know what, I think people who have strings, they're going to want to be able to split them into lists and do further processing on them. So that's it. And now, by the way, I can answer an interesting question. I can answer how many items are in the list. So I'm going to go, at this point, I'm going to go print the length of the list poem. So how many elements are in that list? If I go visualize and go flying to the end, we'll see that there's 217 of them, and it goes up from 0 to 216. Cool beans. All right, so now that's list processing. Now we can get a little bit more. We can get a little bit more here. For example, well, actually, I don't want to give you the example yet. I'm not going to give you the example yet. Okay, so the next thing to do, though, is talk a little bit about sets. Because as you can see, I am trying to get to the point of each word. But in the end, I'm going to want to imagine going through here saying, okay, how many times is much used? And this is not going to be that easy to figure out from looking at this list. It'd be nice if I actually had a unique set of the elements in this list, so that every guy here is only in the set once. Now there is something for that, and that is actually a set. There is something for that. It's actually a set, and I think actually that's why I'm not catching these things. It's right at the end. There's a whole little discussion on sets beyond what the textbook gives you. So let me for now, let me do this. Let's well, actually, you know, let's just screw around right here. Okay, so here's a nice set. So I'm gonna screw around in here. Okay, so if I go run, we get basically a list of these guys. Notice, by the way, the curly braces, I should say. So let me contrast this with this list is equal to, and put this in square brackets. And contrast that with this tuple, which is going to be in round brackets. And instead of print, I'm going to go print the type of the set, comma, type of this list, comma, type of this tuple. And let's just go run and see what we get here. All right, so that means set, that means it's a list, that means it's a tuple or a tuple. So here's the things you guys might remember. First of all, lists are mutable, right? You can start adding to them, you can take stuff away, and there's some other things you can do with lists. Tuples are like immutable lists. You can't change these values. You can't add, you can't take away, you can't change the existing elements, you can't change them. And so what we used them in the previous examples, we use them for more hard-coded things like the days of the week or the days of the month or something like that. A set, what a set does is it eliminates duplicates, among other things. So here I've got 2 cherries, and let me put the 2 cherries in each of these guys right there. Boom and boom. Go run. And of course, now I'm realizing when I did that you're not going to see what I did. So let's do this again. Let's go print. Actually, I'm going to do the same print here, but I'm just going to print each of these guys. So I'm going to go copy, print, and we're going to get rid of the type. So this guy's just going to print the actual variable, print the actual variable, and print the actual variable. And I may actually move this to the visualizer so we can see it. Okay, so notice that this set, when I print it out, it's cherry, banana, apple. I wouldn't worry too much about the order, by the way. But in every other case, cherry is produced twice. So it seems like set actually produces something slightly different. It only produces the unique values. Now, if I go here with this visualizer, go copy, and let's leave here and go paste and hit the enter button. Are you going to get me? Yeah, I got a brand new one. Good, 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 good. So if I go copy and I go paste and I get rid of this print statement, in fact, I get rid of the whole thing. we can actually now, what we can see is this thing in memory. So I go, there's my set, there's my, and so that kind of shows a little bit of some of the differences. So getting back to my initial problem, when I ran this program, and I've got now my set here. This is all the words. If I, sorry, my list. This is all the words in the poem. I now just want to have the unique words. Well, what I can do here is I can go and put this list into a set. Now, I probably need to talk about this a little bit. So let me show you what I'm doing here. These are all me declaring at the beginning of the run, basically, what these are, right? And so when I said this tuple is assigned, I gave it these values and I put it in these parentheses. And what that did is it constructed a tuple. I took these strings and I put them into square brackets and it constructed a list. I took these strings and I put them in braces and that constructed a set. Another way I could have done that is I could have gone that. See how list has got a special color to it? Let's run it and see what it does. So boom, boom, we're expecting all this. And now here's this list, which I should have given it a different name, but that's this go anyway. And this list takes at most one argument. Of course it does. Of course it does. Hang on a second here. Let's make you one argument and let's go list 2 and fix that problem and visualize execution. Get rid of that, rush to the end. All right. By putting my 4 strings into one set of parentheses, it becomes one thing. So one argument, which we'll talk about with functions, one argument that gets put into the function. So anyway, so this list 2 created a list out of that one argument. This is called a constructor, which we'll talk about more when we talk about objects. So what I could do, if I wanted to take, instead of a hard-coded list of values, I could take, for example, a tuple and make it into a list. It's insane but true. I could do this. Watch what happens. I took my tuple, sorry, this guy, and I shoved him into the list constructor, this function that returned a list. Pretty neat. That also means, by the way, if I wanted to, I could take a list and make it into a tuple. It's crazy. It's crazy. Look at the power I've got. It's just amazing. Except I got a syntax error because of that. All right. Apparently I don't have that much power. So I'm going to go next, get rid of my shame, go next, boom. So what it did here with top 2 is it took this list, which is obviously a list, and I fed it into the constructor and it constructed a tuple. You've kind of seen this a little bit when we did goofy things with the integers. Remember that? We basically had x, which was 5. And then if I want the float x, faster than light again, float x is a float x. See what happens there? It's the same madness, right? Here we go. So x is an integer, and then I use sort of a constructor that basically took that integer and returned a float. It's the same kind of thing here, right? We're just doing it with more sophisticated data. All right, so now that I know kind of a little bit about that, what I'm going to do is I'm going to go into my little program here, and I'm going to get rid of this, And I'm going to say, could you make a set chorus poem that is assigned the list, but I'm going to make it a set. Let your, pause the video, let your eyes digest over this, or better yet, follow along. Now I'm going to go visualize, and first step, it grabs the poem. Next few is creating a variable and cleaning it up. The next one takes our work in progress, a clean version of the poem, and converts it to a list. The next step takes that list and converts it to a set. And there it is. Notice sets aren't indexed or anything like that. It's just a straight, here's all the unique words. All right. Now, I don't think length works for a set. So what I'm going to do is I'm just going to go, I'm going to create a, I want to know how many elements are in there. So I'm going to go, X is assigned, actually it might. Python sets, where are my set methods? Is there such a thing to show the length of a set? Length. We're going to do something interesting with them, but no, I don't see one. Let me know if you can see that, but instead what I'm just going to do is I'm just going to convert that set back to a list into another variable here. So I'm going to take the set, put it into a list. That way I can see it in my memory and get a sense as to how big that was. So let's just go flying to the end. So this list is me taking the string and splitting it up and creating a list. Then I take that string and I feed it into a set constructor, and out comes this set. Now, just for my own interest, I'm going to say, well, how many elements are in this set? I can't seem to figure it out as easy. There's other ways I could have figured it out, but I don't know of an easier method at this point. So I'm just going to create a throwaway variable here called X to show that this, as the set gets converted back to a list, we can see that it is definitely shorter. Definitely shorter, only 131 elements versus the 217 elements. So, and you can look through this as slowly as you want, but there are going to be no duplicates. All right, so that's pretty cool. Awesome. And so now the end phase of this particular thing here is we're going to now do the count. We're now going to do a count, and basically we're going to go through this set and count how many times a word is appearing in the list. So just to show that off a little bit here, if I'm just going to go with my, actually, I don't think there's any value. I'm going to do it here. So I'm going to do a count. First of all, I'm just going to go through the list. I'll remind you from the previous examples, if I go for word is in set chorus poem, print the word. I'm not going to run through the whole thing, but I just want to show you that this is going to loop through that set. So let's just go quickly going through this. And so the first word was child. So I must have gone, let's go back a little bit. All right, so here I get the set, and now I'm going to go for word is in set. So the first word is they, right? And then it prints it. And the second word is child. So it's obviously starting to go through that list. That's great. So now what I want to do is I want to say, okay, that sounds awesome. I want to know how many times does that word appear in the set. So here I will actually do this. I'm going to grab this list to demonstrate that idea. All right, and now I'm going to basically say the count is assigned this list dot, and then it's going to be count how many times does apple appear in that list. It only appears once. How many times does cherry appear in that list? That was nice. That was super not helpful. Cherry appears twice. So again, strings know how to do things, and they apparently do know how to count particular words in here. This is why we removed all that punctuation, by the way, because by the way, I said strings. All objects know how to do things like counting and some of the other examples I've got here. Counting, replacing, converting things to lowercase. All objects know how to do things. These things are called methods, right? Or little programs that are attached to objects. So, so in this case, what I want to do is I want to go for word is in there, and I want to say how many times is that word in this list. So I'm going to have a little variable here. I'm going to call that variable count. So count is assigned the list Horace poem count, how many times that word is actually in that list. So let's go visualize and see how this thing works. Fly ahead a little bit. Okay, we do a split. We make a set. We're now going to go through the set. Notice, by the way, how the order just keeps changing. Very interesting. Anyway, we go through the set. We will see the word variable gets created, and it's got the word scoff in there. And now I'm going to go count, which is going to go ahead and see how many times does scoff appear in this poem. And I think it's only once. And it's only once. Great. Then it goes to the next word. We. All right. So how many times does we appear in the poem? We appears twice in the poem. Then it goes to the next word. Tartar, which is probably only once as well. Let's go next. And it's only once in the word. And so you can see that this thing just is going to keep going, and it's going to figure this out as to how many times each word appears. So now the next step is to try and get it to remember things. So I'm going to have a variable here, which is going to be the int max count, which I'm going to assign 0. And the deal is, if this count is greater than the max count, then store that count. All right. So I'm going to say here that if the count is greater than the int max count, and I can assume that the first time it's going to be true, because in order to be in the set, it's got to be in there once. So if it's greater than the max int max count, then the int max count is equal to the count. All right, and then the most common word is going to be the word. All right, so now I'm starting to get into a limitation with the environment, and I can't blame them. At this point, they're going, dude, you've got way too much stuff going on for a demo, is what it's basically saying there. So we may never actually see this run, but let's just go and go through here, right? I don't know how many steps, but somewhere around, if you start to get more than like 394 steps in an actual program, it's going to start saying, dude, you can't do this anymore. But let's just go ahead and see it work at least a few times. So here we got ears. Ears is greater than the max count. And so now ears is the most common word. We go down, we get hair, which is also 1. So hair is not going to be greater. Scoff is not going to be greater. From, kind of surprised at this. Day, arms. But. So but is 3 times. So but 3 times is greater than 1. So now the maximum count becomes 3. And now the most common word shifts from ears to but. And so this is actually doing kind of what we're hoping. So there's dad. Okay, so he is in there. It's 6 times. So now the maximum count becomes 6. And the most common word now becomes he. All right. And so this in theory would run to its conclusion, and then I'd have a little print statement. So that is probably where I'm going to stop this for now. It's because I might have to shift to another environment. But I will say a couple things about this. There's going to be, in my next video, I'm going to deal with the problem that I'm not really interested if he is the most common word, or is, or to, right? I'm more interested in words like is someone, is eyeballs, is Horace, like what, I'm more interested in actual like words that are interesting. And so there is actually a technique to remove words that aren't interesting, so that my my results are a little bit more pertinent. All right, so I'll do that in the in the next video, and I'm going to do that using some list methods, but I'm also going to use a very cool set method, and then I'm going to show you the proper way, right? So you can almost consider a bonus, but it's a good way to demonstrate some of these other ideas.